We'll now be discussing a very important topic, that is the current. What did I tell you about current?
There are organizing flow.
So in this chapter, whenever we say current, we would mean electric current, right? So it's an organized flow of charges. Organized flow of charges. Okay,
Charges. Yes, sir.
that's what constitutes the current, represented by I, and mathematically speaking, current is charge flowing per unit time.
Yes, sir.
Current is charge if it's represented by Q and time represented by T, then we can say that I is equivalent to Q by T.
Yes, sir.
What can you tell me about the SI unit of current?
Sir, SI unit of current.
Mhm.
Sir.
From this equation, can you tell me the SI unit of current? Can you derive the SI unit of current from this equation? Yes, you can. What
Yes.
is the SI unit of charge?
Coulomb.
SI unit of time?
Sir, seconds.
Seconds. So the SI unit of current is Coulomb per second. Now, there was a scientist, his name was Ampere. Now, in honor of him, this Coulomb per second was named as Ampere.
Ampere.
So we can say that the SI unit of current is Coulomb per second or Ampere.
Ampere.
Am I clear?
Yes, sir.
100%?
Yes, sir.
I cannot see you, Hamza. Hmm. Now, electric current is not a vector quantity, it's a scalar quantity. Basically, it's not even a scalar quantity. But at this stage, let's say that electric current is a scalar. It doesn't have a direction, okay?
Yes.
But you'll find in your book there would be a topic called as direction,
Current.
impact, conventional direction of current. Now, we definitely assign a direction to the flow of current. That doesn't mean that it's a vector quantity. Okay.
Yes, sir.
So what do I actually mean? See, these are resistors, right? This is R1, this
Yes.
is R2, fine. Let's say I'm only connecting these two resistors and there's a battery connected to this circuit through this key K. So I press the switch, current will start to flow. Do you know what did I made it? What is this symbol?
But the flow of the current.
No, this is the symbol of a battery. This is a symbol of a battery. This alone is a symbol of a cell. Okay,
Yes.
a big line and a smaller one. Okay,
Yes, sir.
now if you can see, it's basically the repetition of these bigger and smaller lines, right? There's a bigger line, there's a smaller line, there's a bigger line, there's a smaller line, right?
Yes.
That's because it is the symbol for a battery And you know what battery is? It's nothing but a combination of cells. It's a combination of cells. Now, you must be confused about what a cell means, right? Say, for example, have you seen an excited battery of an inverter? Any battery that
Yes, sir.
those tubular inverters have? Do you see there are tubes like this?
Yes, sir.
Okay, fine.
Sir,
So, yeah,
sir, are we talking about this cell? This one?
yeah, this is a single cell, exactly. So
Yes.
their combination would form a battery, fine. But
Yes, sir.
we have that inverter batteries, big batteries
Yes, sir.
that power our houses, right?
Yes, sir.
Okay, so what happens is, you see those tubes there, right? In fact, we
Yes.
call them tubular batteries. Have you checked that?
Yes, sir.
Okay. So each of that tube represents a cell. That's a compartment inside. That's one cell, two cells, three cells, four cells, so on and so forth, and it forms a battery. Forms a battery.
Battery.
Is it clear?
Yes, sir.
100%.
Yes, sir.
Okay, what about this? This is a symbol of a resistance.
Yes. Resistance.
Right? Resistance is anything that puts a load on the battery because of which a voltage drop occurs. I'll explain that those terms later. But yeah, say for example, you have a refrigerator at your home, it's a
Yes, sir.
load, it's a resistor. You have a bulb, it's a resistor, right? Now, can you tell me, if this is a battery, how many cells does this battery contain?
So four.
Exactly. This is a battery comprising of four cells, and each cell is 1.5 volt. Each cell is
1.5 volt.
so 4 volts. Four such cells would give a total voltage of,
So 1.5 into 4 that will be 6.
right? So that's 6 volt.
Yes.
So this is a 6-volt battery. Okay, clear?
Yes, sir.
Okay, great. Now, this bigger line is the positive terminal. This is the,
Positive.
and this smaller one is the negative terminal. Okay,
Yes, sir.
is it clear?
Yes, sir.
This positive, it's always at a higher potential. It's always at a,
Higher volt.
and this negative one,
Lower.
it's at a lower potential. You have to remember one thing, that current current flows from higher potential to lower potential. Clear? Current flows
Yes.
from higher potential to lower potential. Very simple. This is a house. It has a water storage tank at the top, right? It's all connected to those taps in your home, right?
Yes.
So you switch on the tap, water begins to flow, right?
Yes.
Do you need a motor for this? No. It
No, sir.
happens small spontaneously. It happens by itself because there is a water tank at the top that's connected to your tap. Water flows from the higher potential
To lower
to
potential.
lower potential
So
itself.
just like heat flows from higher
Exactly.
temperature.
Exactly. Right? So this kind of potential is called as the gravitational potential
Gravitation.
because this is because of the gravitation. Fine? So gravitational potential. Would this
Yes.
water, which is at the bottom, will it be stored by itself at the top of the storage tank? Will it reach by itself to the top of the tank?
No, sir.
No. Water cannot flow from lower potential to higher potential by itself. It can flow, but it cannot flow by itself.
Yes.
Have I made myself clear?
Yes.
So, what do we need to bring water to higher potential from lower potential?
Sir, gravity or electrical current?
We need an electric motor,
Motor.
right? So, it runs on electricity, right? So,
Yes, sir.
electric energy is converted into what?
Electric energy is converted into
Kinetic energy.
kinetic energy. Kinetic energy.
You know kinetic energy?
Yes, sir.
Energy by virtue of motion. So this electrical energy imparts kinetic energy to the water molecules, and they rise up, get stored in the storage tank. What kind of energy is that? Potential energy.
Potential energy.
That's not even my topic right now, but just to make you understand. And then water will start flowing by itself from higher potential to lower potential because work was done by this electrical energy.
Yes, sir.
This electrical energy did some work which was stored in the form of this potential energy of the water in the tank. Am I clear?
Yes, sir.
So what happened? Water will start flowing from higher potential to lower potential. As simple as that. You got my point?
Yes, sir.
Now, coming back to our battery. So, current, if this is at a higher potential, positive terminal, and this negative terminal is as a lower potential, and it's connected to some load. Won't then current be flowing in this direction? So if current I is flowing in the circuit, this would be the direction of current.
Yes.
Am I not right?
Yes, sir.
Right?
Yes.
This is the direction of
Current.
current. But
Current.
this is called as the conventional direction of the current. Why is it called as the conventional direction of the current? Because basically electrons are not moving in this direction. Electrons are basically moving in the opposite direction. How do you know that? See, say for example, this is a bulb or a metal wire or anything. Fine, it's some kind of metal. Fine. Will it contain electrons? Yes, of course it will contain electrons. Right?
Yes, sir.
So those electrons, will they be repelled by this negative terminal or will they be attracted towards it?
Repair, attracted, sir.
Repelled
Repair,
because they are negatively charged. So
negative
they will
charge.
be repelled. So this would be the direction of the flow of electrons, and it will be
Yes, sir.
attracted to the positive. The electrons will be attracted towards the positive terminal. So this is what? This
Yes.
is the direction. Have I made myself clear?
Yes, sir.
Is there any confusion?
No, sir.
Sure.
Yes, sir.
I think there is some confusion. Conventional direction of current, it has been assigned because of some historical reasons. Fine. But actually direction of flow of electrons is opposite, but it is not going to change anything. Say for example, if I tell you that you are 3 years younger to your sister. Fine. 3 years younger to your sister, or if I say that your sister is 3 year older than you, is it different or does it mean the same thing?
Different.
It means the same thing, darling.
Sir, but it's younger and older.
Huh, but it means the same thing, na?
Ah, yes, sir, yes, sir, yes, sir.
It means the same thing, right?
Yeah.
Either if I say that you are 3 years younger to your sister, or if I say your sister is 3 years older than you,
The age is the same.
age is the same. It means the
Yes.
same amount of, it means the same number of years. Clear? It doesn't matter if I assign the direction of current from this to this or this to this, it doesn't matter at all. Fine? It's not going to change our calculations. Am I clear?
Yes, sir.
100%?
Yes, sir.
Should I move forward?
Yes, sir.
So, what was the gist of this? The gist was that the conventional current is opposite to the flow of electrons. In metals, of course, huh? Correct? So we put these recordings, Hamza, do they help you? Do you sometimes go
Yes,
back
sir.
to these recordings?
Yes, sir. Yes, sir. Yes, sir.
Okay, because we put a lot of effort in making these recordings, okay?
Yes, sir.
Okay. So the conventional current is opposite to the flow of, in other words,
To the
the
flow of electrons in metals.
right, the direction of the conventional. In fact, the direction of the conventional current is opposite to the
That is opposite to the
flow of
flow of electrons in
electrons,
metals.
right?
Yes.
Next thing that we'll be encountering and we'll be studying is resistance. What is resistance?
Sir, general meaning or
Okay, general.
sir, like being resisted or being stopped.
Yeah, fine. I can take that definition. Obviously, this is electrical resistance. So whenever I
Yes.
say resistance in this
Sir,
chapter,
is it when electricity is stopped?
it is exactly. It is not stopped, but when it have some has some opposition to its flow. So opposition to the flow of current, opposition to the flow of current
Current,
is called as resistance.
electrical resistance.
Right. Say for example, this is a wire, has a length L,
Yes.
has an area of cross section A. You know what is area of cross section? Do you know that?
No, sir.
Area of cross section simply means कितना मोटा है कोई चीज. मार्कर का
Sir,
area of cross section
it,
ज्यादा होता है as compared to a pen. This is the area of cross section. Have a look. See, this is a pen. This is the length of the pen. This is its area of cross section. Now, say for example, I have an X here. Fine. This is the length of the X. Don't ask why I keep X here. But okay. This is the area of cross section. The girth of it. Itna mota hai. Got my point?
yes.
I think I made myself right because I don't
Yes.
have any other object to show you. The hell? Get it. Where did you go? So this will be having electrons in it, right? Obviously,
Yes.
millions and millions of electrons in this conductor. Fine. So when this is connected to a battery, these electrons will begin to flow. They'll begin to
Flow.
in this direction, right?
Yes.
towards the positive terminal, away from the negative terminal, right? But while they are traveling in this conductor, they face some opposition. They face some.
Opposition.
This opposition is called as electrical resistance. Now, there's a
Resistance.
reason behind all of this that we will, inshallah, study. Is this clear?
Yes, sir.
Okay. Now, resistance, it's very important. Very important. Resistance of a conductor at constant temperature, if we don't change the temperature, because if we do, resistance will be affected. Okay.
Yes, sir.
So resistance of a conductor at constant temperature depends on, it only depends on two things. Number one is nature of material, nature of material, and number two is the geometrical factors. Now, what does this mean, nature of material? What does this mean?
Sir, how materials built?
Uh, what substance a material is built of? Got it? Say, for
Yes.
example, you have a copper wire, you have a silver wire, a gold wire, right? An iron piece of iron, piece of wire made of iron. You have aluminum, right?
Yes, sir.
What does geometrical factors mean?
Sir, the shape.
Exactly, the shape. So can we say the length? Can we say the area, volume? Yes, of course.
Sir.
Fine. Okay. Should I rub this?
Yes, sir.
So resistance now depends on two things. At constant temperature, resistance will depend on two things. What are those two things?
Sir, the geometrical factors and um, the structure,
The nature,
the nature.
right? The nature of the material. So mathematically speaking, resistance is equivalent to rho L upon A. This is called as rho. It's a Greek letter, rho,
Yes, sir.
and this depends on the nature of material, on the nature of
Material.
only. So say for example, if I have a wire made up of copper, I have another wire, but this is a longer wire. Okay,
Yes, sir.
it's also made up of copper. Will their lengths be same? No.
No.
Will their resistivity be the same? This rho is called as the resistivity of the material. Resistivity. Will the resistivity be the same?
No, sir. No, sir.
Yes, the resistivity will be the same because both of them are made of copper. Didn't I
Uh,
just tell you that it is nature, it is material dependent?
yes, sir.
So if both are made up of copper material, both will have the
Sir,
same
if both are
resistivity.
made of copper material, they will have the same resistivity.
Right. It doesn't matter what their area of cross section is, it doesn't matter what their length is.
Yes.
Correct?
Yes, sir.
Am I clear?
Yes, sir.
Okay, great. Now another look. So R is rho L upon A. I told you that resistance only depends on the length and area of cross section and the nature of the material. Now, say for example, this has a length of 1 meter. This wire also has a length of 1 meter. It has a cross section or cross sectional area of 0.5 mm square. This also has a area of cross section of 0.5 mm square. This is made up of copper. This is made up of gold. Will they have the same resistance?
No, sir.
Will they have the same resistivity?
No, sir.
They won't be having the same resistivity because both of them are made from different materials. Even if their length is same, even if their area of cross section is same, it is as if saying that y is equivalent to zx by m. So even if z is changed, even if x and m are same but z is changed, y will still be changed, right?
Yes,
If
sir.
z and x are constant, m changes, that will change y. If z and m are constant but x changes, that will still change y.
Yes, sir.
So same is the case here. If L and A are same but rho is different, that will still change R. If rho is same but L and A are different, that will still change R,
They are.
right? For R to be same, now let me quote another example. This wire is made up of silver. It has a length of 1 meter, area of cross section of 0.5 mm square. This also is made up of silver. 0.5 mm square, length 1 meter. Will their resistivity be the same?
No, sir. Can you repeat again?
This wire is made up of silver, has a
Yes,
length
sir.
of 1 meter. This is also made up of silver. Will their resistivity be the same?
Yes, sir. Yes.
Yes, their resistivity will be the same. Why, Hamza?
Yes.
Why?
Because they are made of the same material.
Very good. They are made up of the same material. Now, can you tell me, will their resistance be the same?
Yes.
Yes. Why?
Because they are made of the same material.
Resistance, I'm talking
No,
about
no, sir.
resistance.
Because they have the same length and area of
Same
cross
area
section.
of cross section. Got my
Yes.
point?
Yes.
No.
Yes, sir.
100%.
Yes. Sir.
Should I rub this?
Yes, sir.
Can you tell me what is the SI unit of resistivity? By the way, have I defined resistivity?
Yes, sir.
The
Yeah, I have.
definition of resistivity, no, I haven't. The definition of resistivity is roughly the same as that of resistance. It is how difficult it is for the current to flow, for the current to flow in a particular material, right?
Yes, sir.
I'll give you a chocolate if you tell me what is the SI unit of resistivity.
Sir, I don't know that.
Yes, you do know. See,
Sir, is it rho?
no, that is the symbol. That's how we represent it. Now, in order to find the SI unit of resistivity, or like I have told you before as well, in order to find the unit of any damn thing, just check in which equation does this quantity lie. Do you know in which quantity, in which equation rho lies? Do you know that?
No, sir.
You don't know?
No, sir.
Sure.
Oh, yes, sir. R is equal to SL by A. Yes.
I'm booking a ticket and I'm coming to you. Okay.
Yes.
So R is railway, right? So what
Yes.
you will do in order to find the SI unit of rho, you will put it on one side, make this as the subject. Khalid sir might have told you this, making subject,
Yes, sir. Yes, I'm
transpose,
making a subject.
right? So
Sir,
this
R
A will
into
be transformed to the other side. It is in denominator. It will be in the
R into
multiplication.
R into A by is equal to R into A
Exactly.
by L is equal to S.
In order to find the SI units, you will have to write the respective SI units of these things. What is the SI unit of resistance?
Sir,
Oh, I think I didn't tell you that.
no, sir.
SI unit of resistance is ohm.
Sir, can you repeat?
SI unit of resistance is ohm. OHM.
Oh,
And this is the symbol,
okay.
this hat.
Sir, like pi.
Hmm.
Sir,
OHM,
pi
right?
max. Yes, sir.
Am I clear?
Yes.
Okay. So rho will be equivalent to ohm into what is the SI unit of area?
Sir, SI unit of area is sir, meter square.
Exactly, it's meter square. What's the SI unit of length?
Sir, meter.
Meter and
Um,
meter goes. The SI unit of resistivity is what?
sir,
Ohm meter.
meter.
Am I clear?
Yes.
100%.
Sir, how do we pronounce it?
Ohm. Okay,
Yes.
fine. I'll tell you some of the values of resistivity of some of the materials. Say, for example, if we talk about silver or uh, copper, or let's say nichrome and diamond, fine.
Yes, sir.
Silver has a resistivity of 1.6 into 10 raised power minus 8 ohm meter. Copper has a resistivity of 1.7 into 10 raised power minus 8 ohm meter. Nichrome has a
Quantity.
resistivity of 100 into 10 raised power minus 8 ohm meter, which is simply equivalent to 10 raised power minus 6 ohm meter, right?
Yes, sir.
Because 100 is 10 raised power 2, base are same, powers are it, 2 minus 8 is minus
Yes,
6.
sir.
But I have to make a different point here. Behra, diamond has a resistivity of 5 into 10 raised power 12 ohm meter. So, which
Yes.
among the following has the highest value of resistivity?
Sir, diamond.
Diamond. The resistivity is so huge, 10 raised power 12 is a lot of thing. It's 5 million ohm meter. Two
Yes.
times million, right?
Yes.
So, therefore, insulate. Diamond is what?
Insulator.
Because of its huge value of resistivity.
Yes, sir.
Are you getting my point?
Yes, sir.
Are you sleepy?
No, sir.
Okay. What about nichrome? Nichrome has more resistivity or copper has?
Sir, I think sir, I think nitro.
Nichrome, right. So, by the way, any can you name any material which uses nichrome? Do you have heaters at your home?
Heater,
Right.
radiator.
So,
Yes.
so those coils they use nichrome. They are made up of nichrome. Fine. So, because of their resistivity, because of their high values of resistivity, they are good conductors of heat. I mean, whenever electricity passes through them, they produce a large amount of heat. That's another law that's called as Joule's law of heating. Right. So,
Yes.
we'll come to that as well. Okay. Among silver and copper, which is a better conductor?
Sir, better conductor copper.
No, it's silver. The value
Silver.
is just 1.6. For copper, it's
Yes, sir.
1.7. But
Yes, sir.
silver is very costly, right?
Yes.
That's why what do we use for electrical wiring?
Copper.
Copper. Copper is also costly, but not as costly as silver, of course, right?
Silver.
So we use copper
Sir,
and
because I got confused because you said diamond is a good insulator, so I thought silver might be the good conductor.
silver is a good conductor.
Yes, yes, sir.
It
No,
will,
I,
it
I
is
thought you said copper is a good conductor.
okay. Silver is a very good conductor, and followed by copper, followed by nichrome. And diamond is not a conductor at all. Fine, it's an
Yes,
insulator because of its huge value of resistivity. It's 10 raised power plus 12, if you can notice, right?
yes, sir, yes, sir.
Okay, great. Should I rub this?
Yes, sir.
Did you memorize these values? Did you
Yes.
write it somewhere? Because I'm going to ask you these values tomorrow. So what is resistance now?
So resistance, the opposite, like current, like electrical current
Yeah, it is
having
the
a opposition.
opposition to the flow of current. Its
Yes.
SI unit
And
is
the SI
ohm.
unit is ohm.
Ohm. And what does it depend on? It depends on the
It's
nature
the
of the material
nature
and
of.
geometrical factors.
Yes, sir.
Right?
Yes, sir.
Have I made myself clear?
Yes, sir.
So there is another quantity called as conductance. It's nothing but reciprocal of resistance.
Sir, opposite.
Reciprocal. So resistance is how difficult it's for the current to flow. Conductance is how easy it is for the current to flow.
Yes.
It is for the current to flow. Am I clear?
Yes, sir.
100%?
Yes, sir.
Okay. So conductance is denoted by G. Conductance is denoted by
G.
G. And I said that conductance is the reciprocal of resistance. So G will be equivalent to 1 by R, right?
Yes.
So what would be the SI unit of G?
Sir, G is equal to 1 by R, so that means that the G into R is equal to 1.
R, the SI unit of R is ohm.
Yes, sir. Ohm. Yes, sir. Ohm.
So can I say that it's ohm inverse?
Yes, sir.
Ohm inverse is called as mho, MHO mho,
Yes.
and it's also called as Siemen. Got my point?
Yes, sir.
SIEMEN. Correct?
Yes, sir.
So what is the SI unit of conductance now? Siemen.
Sir, yes.
Right?
Yes.
Did you get it or did you not get it?
Yes, sir. I got it.
Okay. So two quantities, resistance and resistivity.
Yes, sir.
Resistance depends on nature of material and geometrical factors. Now conductance we discussed. On the similar lines, there is another quantity called as conductivity. It's called as,
Conductivity.
it's denoted by sigma. Fine. And
Yes.
conductivity is the reciprocal of resistivity. Do you see
The connection.
this connection, the stark similarities?
Yes, sir.
One is resistance, another is conductance. One is resistivity, and the another is conductivity.
Yes, sir.
So this is reciprocal of resistivity.
Yes, sir.
Correct? So sigma is 1 upon rho. Fine. Now what is
Yes, sir.
G equivalent to? 1 by R, right?
Yes, sir.
What is R equivalent to? Rho L by A?
Yes, sir.
Won't it be reciprocated and it will be A by rho into L? It will be reciprocated, na?
Yes, sir.
Do you know that?
Yes.
100%?
Yes, sir.
Can I write it like this? 1 by rho into A upon L? Isn't it still the same thing?
I think yes, sir. It's the same thing.
Yes. Fine. Now, what am I going to do? Instead of this 1 by rho, can I write sigma? Can I? Can I
Sir,
write
instead
sigma?
of.
Instead of this 1 by rho
Yes,
here,
sir.
can I write
Yes, sir.
sigma?
Yes, sir. Because it's sigma is equal to 1 by rho.
Right. So that is sigma into A upon L.
Yes, sir.
So can I say that conductance is equal to
Sigma
conductivity.
into A by L.
Exactly.
Yes, sir.
Can I say that?
Yes, sir.
Now, can you tell me the SI unit of conductivity?
Sir, conductivity, right? So the uh, conductivity.
Make sigma the subject.
Yes, sir.
Tell me quickly. I'm waiting.
So, um, sir, is it uh, sorry, just a second.
Turn on your camera, Hamza. I'll show you.
Sir, I think it's Simons per meter.
Have you calculated it anyway?
No, sir.
Did you Google it?
Yes, sir.
Okay. Very good for being honest. But see how we are going to do it because we should know, right? Did I just tell you that in order to find the unit of any quantity, I must know in which equation does this lie. So this time, if I'm asking you to find the SI unit of sigma, do you know in which equation it lies? Yes, of course you know. It
Sir,
lies in
yes.
this equation. G
Yes.
is equivalent to sigma A upon L, right?
Yes, sir.
Okay. So what about this sigma? You will make this sigma as subject. This L is in the denominator. Transpose it to the other side, it will be in the numerator. This A is in multiplication. Transpose it to the other side, it will be in the denominator. Then you will be having sigma.
Yes, sir.
So sigma is now the subject, right?
Ye- Yes, sir.
So sigma will be equivalent to G into L upon A.
A.
Now, what is the SI unit of G conductance? Isn't it Siemens?
Siemens, yes, sir.
What is the SI unit of length?
Yeah, yes, sir. Yes, sir. Yes, I got it now. I got it now.
Yeah,
Meter,
now
and then it's meter there, and then meter square. So the meter and meter will be yes, and then it's Siemens per meter. Yes.
so this is how you will never forget this concept, inshallah,
Yes, sir.
right?
Yes. Yes, I know.
So a quick
So for
recap.
if you have to find one, if you have to find a SI unit, what we have to do is, for example, if it's sigma is equal to G, for example, it's if it's G is equal to sigma into A by L. So
Mhm.
what we have to do is we have to make sigma the subject. So it will be the sigma the subject. So sigma is equal to G into L by A, and then we have to write the SI units of the each one
Right,
respectively. So conductance is Siemens into meter by meter square. So the meter and meter will be removed, and then meter will be left.
correct. So
So it's
Siemens per meter, right? A quick recap.
yes,
The SI unit of resistance is what? Ohm.
sir. Ohm,
The SI unit of resistivity is what?
sir. Ohm meter,
Right. The SI unit of conductance is what?
sir. Siemens,
Siemens. Very good. The SI unit of conductivity is what?
Siemens per meter,
Siemens per meter. Right. So resistance depends on
sir. Resistance depends on the nature and the geometrical shape or geometrical. Uh,
mathematically what is resistance equivalent to?
Sir, resistance is equal to resistance. So, sir, resistance is equal to rho into L by A.
Very good. Correct. Any confusion so far?
Sir.
No?
No, sir.
100%?
Yes, sir.
Okay. I hope you understood everything that I taught and you
Yes.
enjoyed today's lecture.
Yes, sir.
Okay, then that would be it for now. Inshallah, see you in the other class. Okay?
Also, sir, sir,
Mm-hmm.
I finished those papers. Do I have to send them to you?
Yeah, send it on info@curiesclasses.com.
Okay, sir.
Okay. Take care.
Allah Hafiz, sir.
Allah Hafiz.